Thank you everyone for joining. Today is the Azure Power Lunch series. Today we're going to be covering Azure Database for PostgreSQL. I'm going to share my screen now. Of course, if you have any questions during the presentation, feel free to drop a note within the comments, and then I'll keep an eye on that as we go, as we progress. So today we're covering Azure Database services for PostgreSQL. This is an open source platform, but it's a managed solution, a PaaS offering offered within Azure that you can leverage and utilize. So what we're going to do is we're going to cover a couple of recent updates. We're going to go into key topics of Azure Database for PostgreSQL. If I have some time, I'm going to show you a couple of things, and then we can do a Q&A towards the end. But of course, if you have questions, feel free to drop them in within the comments. So if you can always go online to azure.microsoft.com/en-us/updates, and you can go in and pull the most recent updates among the different Azure products. You can do a search in there for PostgreSQL, and that would also give you the most current updates. A few current updates related to the service. The most recent one is from February 7th, where it was announced for Azure Database PostgreSQL would have read replicas. This is in preview for the ability to have asynchronous read up to 5 replicas. That is more of a manual configuration process, but that is a feature that was recently announced. Another update that was recently announced on January 23rd was the Azure Database migration service would have the ability to migrate Amazon PostgreSQL from Amazon RDS to Azure Database for PostgreSQL. And in another recent update, also related to Azure Database for PostgreSQL, but specifically for the Azure Database migration service, was the ability to migrate PostgreSQL databases online. And that was put out on January 9th. To kind of briefly mention today, and I'll spend roughly about 20 minutes on that, which are availability and performance, security and compliance, manageability, monitoring, and tuning with Azure Database for PostgreSQL. Now, as far as availability and performance, this is a PaaS offering or a managed solution. So even though it is built off open source technologies, and also keep in mind that the Azure Database for PostgreSQL is based on the community edition of PostgreSQL. So that's something to keep in mind as well. So all the functionalities you would more have towards the community edition. It does have built-in high availability with that given SLA of 99.99%. It can scale in seconds. Again, this is a managed solution, allowing for that scaling of the underlying infrastructure pretty easily, and I'll show you that in a little bit. You can rely on easy and cost-effective disaster recovery based on the backups. Backups are handled for you because it is a PaaS or managed solution. And those are handled at specific intervals for the full differential and log backups. And you can build on your terms with this platform. It can support your various needs based on scaling and performance, which you get to kind of pick those options, what tiers you want, what level of performance you want, how much storage you want, and storage and compute can actually be scaled independently as well. You can also decide if you want to do how you want to handle the backups as well, which we'll get into a little bit. So as far as built-in high availability, this is going to be familiar to those who are already familiar with Azure SQL DB, the Azure SQL DB service, and some of the way it works. But the underlying principle is that as you have, your application will connect through a gateway, which actually points to your PostgreSQL server, which is utilizing storage. That storage is actually written 3 times so that you have multiple copies within that same data center region. And then also what happens is that if you lose that one storage, basically another storage is brought up and it's replicated and copied. So you have that 3 copies of your storage. But then also if the server has an issue and it goes down, another server basically brought up an instance, which is brought up very quickly. And then you basically attaches to that storage, and then you basically the gateway will repoint it to this new server. So from your perspective, you still have the same server name, everything remains the same. You don't have to make any changes on your client, but that high availability is already built in. So in case there isn't something that happens behind the scenes, you don't have to worry about having to build a new server or provision another resource from that high availability perspective within that data center. From a security compliance perspective, you have multiple aspects within the managed solution or this PaaS offering of Azure Database for PostgreSQL, giving you the ability to control access, whether it be the access control layer, whether it be security built in for SSL in the traffic, whether it be the encryption basically in REST or in motion. You have several firewalls, you have VNETs that can actually further refine your security. And then you also have the security that you're familiar with if you use PostgreSQL or that native PostgreSQL security model. So you do have those multiple aspects or multiple levels that you can kind of take advantage of from a security standpoint. From that aspect of the access control, right, when someone is trying to connect, by default, Azure Database for PostgreSQL is going to have SSL enabled. So when you go to connect to it, it'll have that SSL for that data in motion. It'll connect to that through the gateway and into the firewall, which is at the server level for Azure Database for PostgreSQL, where you kind of defined, who can connect from what IP addresses. And then from there, it's going to go and connect to that native authentication within PostgreSQL to determine who can access what sets of data. You can set the firewall settings for this server via the portal for a familiar interface. You can also use CLI or PowerShell, but you just keep in mind that it's at that server level. So any database, it's going to connect to who can determine who can reach through that server. So once they can reach through the firewall, then they can access the databases that are assigned to that server. That's the one thing with it being at the more of like a server aspect is all those databases also share those resources that you've allocated. That's another thing to keep in mind, which we'll get into in a minute. Another aspect from the security standpoint is the service endpoints and being able to adjust how people or who can connect. And what I mean by that is Azure Database for PostgreSQL using the Azure SQL DB service principal also has a public IP, right? So people would actually connect to that public IP. With VNET service endpoints, you can set that service to only respond to that particular VNet or subnet, so that you can say, okay, I want to have the routes or the access go through that specific VNet, and then that way it's responding based on traffic from that particular source, as opposed to the public IP. You can't remove the public IP. The public IP is still there, but you can prevent it from trying to who can access that server, whether that's accessing from that public IP or via the actual VNet. So from a manageability perspective, there's a few items I wanted to cover on that front. It does have the built-in backups and restores. There's advanced monitoring and alerting capabilities. You have intelligent performance tuning, and there's also some AI-based security protection, which is a feature within the Azure Database for PostgreSQL. From a backup and restore perspective, you do have local redundant storage for backups, and you have geo-redundant backups that you can take advantage of. That's set at the creation or of the allocation of the resources. So when you go in and you say, okay, I want to have this create or allocate this Azure Database for PostgreSQL, one of the screens you'll have is a backup redundancy option with the pricing tier, and you pick local redundant or geo-redundant. And that would give you the ability to have geo-redundant, giving you the ability to have that from the more of a disaster recovery aspect of it, to be able to retrieve those backups from that geo-dispersed location. That setting is set at the creation point of the resource. So of course, that can't be changed later, but you would pick that when the resource is allocated or created. You also can set the backup retention period from 7 to 35 days. And you have that point-in-time recovery based on that 35 days. So you can do point-in-time recovery. When you do point-in-time recovery, you would basically, in that graphic towards the bottom right, you get to pick a different server name. So you would restore to a new server, and it would restore those databases on that server to that new server name based on that backup that you chosen at that point in time. But the backups are built in, of course, for you. You don't have to worry about that. The backups occur weekly for full backups, and we have backups that occur for differential backups daily. And then, of course, you have the transaction log backups to be able to do those point-in-time restores. You have multiple metrics that you can take advantage of to monitor your performance. You can monitor things such as your CPU percentage utilization, I/O percent. You can monitor some of the things on the network side as well as your storage. There is some configurability as well as far as the minimum amount of time frequency for those metrics. And you can also integrate it with Azure Monitor to be able to do things such as stream those metrics to Event Hub, to archive it to Blob, and then to be able to have that visual interface that you can actually take advantage of and leverage. There's also server logs for Azure Database for PostgreSQL. Those are the built-in server logs. You can actually, if you enable the functionality, you can also download those server logs if you so desire to do so. You can configure that log retention, and these are all for the configuration of the actual server. Those are parameters within the portal that you can actually set. So you have things such as log duration, log disconnections. You can log the number of connections. You can log connections. You can log checkpoints, and then of course you can set the retention and you can also take advantage of the statements that are being logged and utilize that for performance issues. You have a few other monitoring capabilities within PostgreSQL. If you're familiar with PG statements or PG stat statements, you can utilize that as well as PG buffer cache. Those would be extensions for PostgreSQL, but they're there by default for when you allocate an Azure database for PostgreSQL server. So you can actually take advantage of those as well. As far as the PG statements track, that's a configured parameter that you can configure and turn off or set if you want top or all as well. You also have query store that you can take advantage of. If you're familiar with Azure SQL DB and the query store there, it's a similar functionality. So you can take advantage of the query store to be able to basically look at your performance on your queries and do other things. So a question, a statement that was brought up here is the versions of PostgreSQL. So correct, it does currently support 9.5, 9.6, and 10.5. Is this version related to AWS or customers still behind with the version? So the Azure database for PostgreSQL within Azure, the Postgres versions, it's usually an N-2, right? So as far as what version it actually supports, the current offering supports being 9.5, 9.6, and 10.5. And those are based on the community editions of PostgreSQL. So the principle being more like the N-2 as far as what's going to be offered within the offering for Azure Database for PostgreSQL, but it's based on the community edition for those. So if you were going to go, if you're familiar with PostgreSQL and what versions offered in the community edition, currently Azure supports the 9.5, 9.6, and the 10.5. You also have advanced threat protection. So with advanced threat protection, that gives you the ability, and you basically just have to turn it on. So it's an additional option that you can actually enable. But that'll give you information on potential activity that's happening against your Azure database for PostgreSQL, for potential alerts for things that may be investigated for suspicious behavior patterns, connections. So that's another feature that you can actually enable from a security standpoint and take advantage of that as well to look for any attempts to breach your database. So in summary on this material, like I said, I want to kind of get into a little bit of a demo and then a couple other best practices as well. But in summary, the aspect is that you have what you currently do versus what the past can help you with. So currently, from an infrastructure perspective, having to purchase and manage your infrastructure, you have the infrastructure is managed for you, so you have the ability to utilize that infrastructure and scale on demand as needed. There's some caveats to that, and I'll show you here in a second. You being able to protect your data. So you do have, and being able to utilize those data, the backups are handled for you with point-in-time restore. What you would normally have to do is configure and set up that high availability implementation. On the PaaS offering, a managed solution, again, that's handled for you with that 99.99 SLA, so that you don't have to worry about that configuration of your multiple servers to handle high availability. Again, that's high availability. From a disaster recovery implementation and having to worry about that, with the PaaS offering, from the backup storage, you have geo-redundancy capability and geo-replication of that underlying data. Again, that's at the backups, which are handled for you from a DR perspective. So you can set that up for that geo storage rather than the local redundant storage for your backups. You have the compliance. You have easy-to-use features that you can use to make sure that you meet those compliance needs. You can secure your data from your malicious users and mistakes. Of course, with that one that was mentioned was ATP, Azure Threat Protection. And then you also have other things as well, firewalls that you can configure. You have like I said, the VNET service endpoints that you can leverage to minimize the footprint. So there's easy to use features that you can take advantage of from that perspective as well. You have the ability to roll out updates and upgrades, right, when you're currently working. Now, PaaS helps with that as well. So the updates to minor version updates are applied for you. You don't have to worry about that. Now, upgrades to a major version, like say, for instance, you wanted to go from 9.5 to 9.6 or from to 10, that you wouldn't do on the fly within that particular allocated server. You would actually you would spin up a new server and then have to migrate that. And you can use PG dump, PG restore as part of your migration plan. You can use DMS, but PG dump and PG restore is something most people that utilize PostgreSQL are going to be familiar with, and you can leverage that as part of that process to move from one server to another, especially as part of an upgrade plan. You have normally you would have to worry about monitoring, troubleshooting, and managing at scale. So you have a lot of easy to use built-in features that you can take advantage of from the monitoring, and also to help you troubleshoot, like for instance, query store, PG stat statements. One thing to keep in mind is when you use PG stat statements, and in some of the other ones like the query store or the query caching, buffer cache, is to keep share when using those. Is if you turn it on to all, of course, you're cataloging all this information or capturing all the query capture. If you set it to all and you're catching all the queries, that could potentially impact your performance. So rule of thumb, if you're in a production system, and a best practice kind of scenario is, unless you need to have those enabled for a specific reason, set them to none so that you have the best performance. You have as far as the work you would normally do, tune and maintain to make sure you have that level of performance you're looking for. With the PaaS offering, you also have those built-in features to help you with that. Again, using things such as your query capture, your PG stat statements, the query store, and you can leverage those to kind of look and maintain and see how you can tune your database. You also can scale on the fly, right? And scale independently the storage as opposed to the resources that you need. I wanted to kind of cover a couple of best practices as well as part of this. So from a best practices point of view for business continuity, usually recommendation is to select geographic redundant storage so that you can have the copy and your database backups being replicated across the geo-dispersed location. And so you can actually restore, and that also gives you the ability to restore to a new server versus the local redundant, which you wouldn't have that capability. A couple key considerations is the point-in-time recovery, as I mentioned, creates a new server. And you can't change again, like as I mentioned, you can't change the backup redundancy option once the server is created. A couple of best practices related to choosing the right tier. So one of the recommendations with basic tiers more suitable for very small websites and usually towards dev and test workloads. And you can find this information on the online documentation as well. General purpose and memory optimized. The memory optimized is going to give you that really good price for performance for your database workloads. Some best practices for choosing the optimal SKU. So your max connections is related to the number of vCores that you're selecting or for your performance at scale, and also that memory, right? As also per the vCore. So keep that in mind. As far as your max connections, it depends on the number of vCore, which is mapped to your performance in memory. Your IOPS is also related to the amount of storage you're selecting. And again, this is for general and memory optimized. Basic, you don't have that ability to get the higher IOPS by scaling this storage. But with general purpose and memory optimized, as you scale your storage up, you basically have approximately 3 IOPS per gigabyte up to a max 6,000. So that's something you can look at, and that shows up in the portal as you're scaling. Some best practices for metrics is to monitor your storage use, storage percentage, and also always remember to configure alerting so that you can have that and be notified for different events. Another thing to also take into mind also as you scale up storage is you can scale up storage, but you wouldn't scale down your storage, and I'll show you that here in a second. Some other best practices for metrics is to monitor your I/O consumption percent, and that's going to be important so that you can know how to scale, right? And again, your IOPS is directly related to your storage on the general and memory optimized storage tiers. IOPS to max being 6,000 IOPS, which is anything if you scale above 2 terabytes, you're not getting more IOPS per storage. But keep that in mind as well. Monitor your CPU percent and memory percent. Again, remember to configure alerting. And then another thing to keep in mind also is when you're connecting from a VM, let's say you have your application connecting on the VM, is to use accelerated networking to minimize any latency that you may have from your VM. Accelerated networking being configured at on the VM itself, and just to make sure that you're taking advantage of the best minimal network latency. I wanted to kind of show you also, just wanted to bring this up real quick. Here's a VM that I have right now that I'm connected to a demo Postgres Azure Database for PostgreSQL instance. I wanted to show you a couple different things on here. One is not necessarily the host name, but the port is going to be the same port you're familiar with, but also the username. So when you're connecting to an Azure Database for PostgreSQL instance, you're going to have your username, but you also have this @ and then the name of that server, right? You don't need the full host name, but it is that name of your server instance is appended to your username. So when you connect, you actually use that. So that's one thing I wanted to kind of bring to your attention. Another thing that's pretty popular with PostgreSQL is the extensibility or the extensions. And with Azure Database for PostgreSQL, you also have the ability to leverage extensions. You can always see what those extensions are by running this command, select * from pg_available_extensions. And that's going to give you that list of all the extensions, which ones are installed and what versions are available to you, so that you can actually either run a create extension command to install those extensions. As an example, for anyone who may be using Postgres or PostGIS, you have that there as well. You have some other ones as well, including DB-Link, for those who may want to use DB-Link to have PostgreSQL database communication on the same server, to have multiple databases communicating with each other. And you have a few others as well that you might be familiar with. So you can always take a look at that. And these are also online and documented. You could also use, if you're familiar with using pgadmin, you can always install the extensions by just going to create extension from the extensions options. So another thing I kind of wanted to bring up is this is a managed solution. So being a managed solution, you don't have access to the underlying file structure. You don't have access to the underlying services, right? So for instance, the container that runs behind the scenes. So there's certain things you wouldn't be able to do. So any commands that you would normally be familiar with that allow you to configure things at the file structure level, at the server level, would be something you wouldn't be able to run. For instance, create table spaces. Or so something like create table space, you wouldn't be able to do because that's actually setting up your file structures. So just keep that in mind as well. But as far as creating users, you have that ability. There are some default user roles and default users, so that you keep that in mind. So, but if anything that would need the super user role or the super user access, you wouldn't have access to. So super user is kept for the actual service, even though if you were to look in, you would actually see the super user account, right? So you can see it, you just can't leverage the super user. PG admin is a default one that you set up when you actually create the service. You'll select the user account that will be worked with this particular role, the Azure PG admin. I want to cover a couple things on the portal. A couple things I want to bring to your attention as well is when you're allocating these resources, if you've allocated a basic tier, then you can't scale up or to general purpose or memory optimized. Basic doesn't have the ability to scale up to the different pricing tiers. So when you're basic, you're in basic, and you can't go from general purpose back down to basic. So if this was a basic one, these would be locked out as this one, the provision is general purpose, basic is locked out. But I can go from general purpose to memory optimized. And then, of course, you have the different compute generations that I can pick from, Gen 4, Gen 5. And from either general purpose or memory optimized, I can scale that. I can scale my vCores, of course, and I can change my backup retention period as necessary. But again, the backup redundancy option, this one was selected as geo-redundant, so I can't switch this to local redundant because it was created as geo-redundant. That's also set. And also my storage, I can scale up. But when I created this one, I had it set as created it with 1052 gigabytes. So I can't scale it down. That scales up for the storage. So those are just some things to keep in mind when you're setting up your instance and when you need to scale your resources. Are there any questions? Any questions anyone would like to ask related to the Azure Database for PostgreSQL service? If there are, you can post them within the comments, or if you want to come off mute and ask a question, that's okay as well. Just looking on there to see if I see any questions related to the service offering. Do you have any questions about the way the configuration occurs? Any questions about the compatibility? I don't see any questions. Any more questions? Just the one from earlier. If nobody has any questions, we'll be able to wrap up here in about a minute. Give it a little bit longer in case there's any questions anyone has related to the service. Again, just a reiteration of the fact that this Azure Database for PostgreSQL is open source, based on an open source platform, and is based on the community edition of PostgreSQL. Well, thank you everyone for joining. It doesn't sound like there's any questions, but I appreciate you all for joining today. I'm going to be stopping the recording now.